GenAI really makes my life easier. Whenever I have a complex or delicate email or text to write, ChatGPT really helps. Today, we will look into how you can build GenAI apps on SAP BTP. And by the end of the session, you will learn how to quickly use large language models and build GenAI apps with SAP BTP services. A warm welcome and thank you for joining our session. Quick start, build GenAI apps on SAP BTP in minutes with GenAI Starter Kit. I'm happy to have here with me 3 experts. Let me introduce the awesomes. Nogueira, Vice President, Intelligent Enterprise at SAP Foundation. And Evgenii Skrebtcov, Architect, Development Architect at SAP BTP AI team. And Peter Conrad, Chief Development Architect. And now, without further ado, let me hand over to Rui.
Yeah, thanks a lot, Tania, and thanks a lot, everybody watching in. So today we want to actually show you how the BTP GenAI Starter Kit works, how you can actually do exactly what Tania just explained, really getting started within a couple of minutes with AI or GenAI on SAP Business Technology Platform. But before we actually go into the topic, let me just quickly share a slide with you to give you some more background. Let me just see, voila. Sharing my screen. So let me just maybe start by explaining what is inside the GenAI Starter Kit. So it's first of all the piece where it's setting up the whole infrastructure that you need, meaning setting up your sub account, putting the right services into your sub account on the SAP Business Technology Platform, and then also configure and deploy the large language models that you actually need.
Sorry for interrupting you, but you are sharing everything.
So, okay, I see. So let's see. Is this better now?
Definitely better.
Okay.
Thank you.
Yeah, thank you so much, and sorry for the hiccup. So in essence, that's the first point, right? Setting up the whole infrastructure, and that's something that is done automatically using Terraform. We will get there in a minute. And then we have several examples which actually show you how to use then, once you have the infrastructure set up on BTP, how to use the underlying large language models that you can configure, then to use, for example, RAG, Retrieval Augmented Generation, in SAP Business Technology with some very simple examples. In this example, the first example that we have in the repo, it's actually showing how you can read in, for example, documents or markdown documents from GitHub. Then we have advanced RAG patterns that we will show you also during our session today, and then also giving some more ideas how to work with vision models, where you actually can work with pictures and then depict from there information that you can use to work with. And then last but not least, also have this RAG pattern on structured and unstructured data. So let's now go into the point how we can be more efficient building GenAI apps with the Starter Kit. And we are actually doing this with a 3-step approach. In the first step, that's what I actually explained before, we are setting up the complete infrastructure with a Terraform script. For that, we are using the Terraform provider for SAP BTP. And with that, you set up the SAP AI Core Service, you set up the HANA Cloud tools with the HANA Cloud Vector Engine. And also optionally, you can set up also the AI Launchpad with just a few clicks and entering information about your global account, for example. And at the end of this first step, the result will be an environment file where you get already some metadata that you will then need for the second step, which takes around 4 to 5 minutes if you're doing it in the code, where you're actually configuring the AI core services to use the specific AI models. So you might know the SAP BTP AI Hub, which actually provides you all kinds of large language models from various vendors. And with that, you can pick and choose actually in the GenAI Starter Kits which ones to take. This takes, as I said, something around 4 to 5 minutes. And once this is done, the environment file will be finally filled up with everything which is necessary. So including also the data for the large language models. And in the last step, it's actually applying now exactly what we have set up before, and then actually using the sample codes that we have put together for you in very easy way by simply connecting to this environment file all of those scripts written in Python, because that's normally the programming language that you use for AI use cases in general. And that's actually how it works in the end. And what we have here in addition is also how these how the AI Hub is actually integrated into all the applications pretty nicely. So meaning that the applications you can build can rely really on a very strong foundation that the AI Hub provides to you to run your AI use cases. Before now going into the whole topic, I wanted to explain briefly what Retrieval Augmented Generation is, but let me maybe keep this for after the whole setup, because I can already sense through the line here that everybody is curious to see this up and running. So let's leave this here for showing in a couple of minutes, because what I will do now, I will switch over to the starter kit, because maybe one of the first questions you would raise is, okay, how can I get hold of the whole BTP GenAI Starter Kit? Voila, here it is on GitHub, github.com, SAP samples BTP GenAI Starter Kit. We will also put the link then later on in the show notes here of the webinar here on YouTube. And it actually contains everything that we will be showing. So including the three-step approach that I just explained briefly, as well as the requirements that we have to use this, like for example having a global account on the SAP Business Technology platform. Also, ideally you have Visual Studio Code, which makes things much easier. And then also how you download all of this and how you set it up. So what I have done to get this now started, I have already done this, meaning cloning the GitHub repository into my Visual Studio Code. That's actually what you see here. And what I did as well, I set up here my global account. So I followed actually the instructions on a GitHub repository, provided here who the administrator is for all of this. And the only thing that you need to do, and I just started this 10 minutes ago, right? So that we don't have to wait until the script is ready, because it takes something between 10 to 15 minutes. Let me just scroll up here in my screen. The only thing I do is just typing run, right? So, and if I type run, it actually goes through the first step. And those of you who are familiar with Terraform might already understand what is happening here, meaning that Terraform has been initialized, and now actually Terraform goes through all the resources that have been defined and creates the corresponding sub-account on BTP, assigns the respective role collections to the users. And then you see here already how to set that it's creating via a module the setup of the AI core service. And at the end, and many of you might know this and have already seen this, when you use Terraform, you actually see how the Terraform plan is being executed. In this case, doing exactly what I described before, setting up a global sub-account, setting up the AI core service, as well as the HANA tools, along with the vector engine. And you see here, while I scroll down, how this actually happened. And you see here the HANA Cloud's instance took roughly under 5 minutes to be set up. And at the end, we see here that 13 resources have been added. And at the end, that's a second step, which is executed automatically. Now the large language model is being set up that we wanted to use. The actual scripts, and that's the beauty now of it, to run the setup of the infrastructure, you can actually see under scripts, step 1, set up infrastructure. This is the main Terraform file explaining exactly what is done in which sequence, so you can have a look into it. And the corresponding environment file has been set up, which contains the URL and also the password to your HANA database, which actually already has the vector engine built in. And what I'm sharing with you now is actually exactly this sub-account that I have just created. Let me just share with you. This is my account. You can also see here my name, and I created it just 10 minutes before starting this webinar at 2:50. And now let's have a look into the GenAI Starter Kit. And we can already see here that the HANA instance, as well as the AI core service, as well as the HANA Cloud application, has been set up. So meaning that the whole point around step 1 has been executed properly. So if we look at this picture, right, this one is step 1 about setting up the infrastructure. Step 2 is about setting up the AI core service itself with the AI models. That's what you see here in the log as well, how actually the access tokens from the AI core system have been fetched. That takes a little bit, and then at the end you see here that we have created we have configured the AI core service to use 4 large language models: the Anthropic Claude 3 Sonnet, GPT-35 Turbo, text embedding ADA 002, and GPT-4o. So meaning after this, everything is ready to go. And you see also as well that the environment file has been created that is now the basis for our first example, right? So meaning we are here in the main folder of the starter kit. And what I do now, I just jump to the scripts folder and jump to the third step, which is now about exploring the examples. And you see here the 4 examples we have talked about before in the first slide. And we will start with the first one about naive RAG. So a very easy way to do RAG. And before going into it, maybe Evgenii, do you want to maybe explain to our audience about the RAG pattern just in general, so that people understand how the RAG pattern works? Is that okay for you?
Yes, absolutely happy to do so. So basically, this is one of the most common patterns that we see in the enterprise application, and we can explain it quite easily with this diagram. By the way, that I've linked to the image source, to the amazing article. Highly recommend to read it if you're interested in the details. But basically, normally, when we communicate with a large language model directly, it is practically frozen. It means that it has a certain knowledge cutoff. It is also can suffer from hallucinations and so on. So it may return inaccurate information. It definitely lacks the business context of our specific domains based on the proprietary data that you may have for your organization and so on. So basically, this data was not seen by the model during training, and it may have hard times arguing and answering your questions related to a specific super narrow domain or recent actual events or events that happen in your enterprise or in your business. And specifically to overcome some of these limitations, we use the Retrieval Augmented Generation pattern. So basically, we add an additional step before we pass the question from the user to the LLM with retrieving the relevant documents and passing it as a context to the LLM. So at the end, large language model receives not only the original question, but also the information that is relevant and can be used as a source for grounding the response of the LLM. And as you can see here, the LLM oftentimes instructed to base its response on the specific information and specific context that was provided to the model. Oftentimes, it's also instructed not to invent anything on its own, only use the sources for grounding, and if it cannot answer based on the provided context, just submit this and reply that I do not know. Why this is done, it helps a lot with explainability, because in the RAG-based applications, it can oftentimes show not only the answer from the large language model, but also explain which sources were used during the generation of a response. And here, a very important step, what really highlights, is the indexing part, where you need to pre-process the relevant documents or the relevant information, which may come in different ways, that will be relevant for this retrieval step. And in the very simplistic case where we start, which is nowadays seems to be the common terminology to call this a naive RAG approach, we would use some sort of similarity search. And probably the most commonly used one is a vector similarity search to retrieve the from the knowledge store, to retrieve the pieces of context from the knowledge store that are relevant to the question that the user is asking.
Yeah, thanks, Evgenii. So, and to see this actually in live, we have now, as part of the starter kit, this what we call here the naive RAG example, right? And with within each of the folders, you also have a respective README MD file, which tells you now exactly what to do. So in our case, it tells us to create a virtual environment for our Python environment. So we do this with poetry install. And by the way, for you wondering what you need to install, you actually don't have to install anything, because as you are using Visual Studio Code, we actually provided here as well a so-called development container. And this actually has everything inside this project, so that you don't have to install anything, right? It's all part of the dev container. The only prerequisite is to have Docker up and running, and then actually you can run this whole environment preset for you without having to install anything. So we did the first step to do the poetry install, and now we actually run the actual application, which is here, the main py. So we just type poetry run python main.py, and this specific example now goes through a simple application that we built by connecting to a Git repository. And in your case, it could be, for example, a Git repository which is only available within your internal network, right? And we would do exactly what Evgenii just said in the first step, to actually ingest this information, which is internally, into our HANA cloud instance. So, but before we do that, you see it provides us here with 4 options: clean up database, ingest, and retrieve data, or exit. So let me just start to clean up the database. Okay, nothing to clean up, everything is fine. And now if I type in ingest data, what happens now is the application, and you can see in the code how this is done, is fetching from a GitHub repository markdown documents. And these markdown documents are now, you can see it here, split into 81 documents, or sorry, split into 323 chunks. And each of the chunk is now vectorized in the HANA database and are added along with the vector results. So meaning now that we have we ingested the data from, for example, an internal resource that you have, we can now actually ask questions based on that data, right? And if I type in here number 2, it's actually, in this case, it's fetching information from the Terraform webpage that we have, where we have certain markdowns files. But I will just ask now, okay, what is SAP, what is the Terraform provider for SAP BTP? Of course, this question a large language model could also ask, respond without the rec pattern, but I'm just using this as an example. You could now also create a question which would only be available for people who have information that is within the scope of a document you have shared, right? And you see now here, it tells you, okay, if you don't know what Terraform is, it provides you some fundamentals from the hashicorp.com, and then for best practices, it provides you some information about the SAP BTP provider. And in addition, it also tells you, also pointed out as from Evgenii as a good practice, to also show you where the source came from, for that this information is grounded on, right? And that's a very nice way to actually see the rec pattern in action. And due to the fact that you have all the source code for this application inside the repository, you can actually go into the code, try to understand how this works. And remember, this is a starter kit, right? Although our examples are quite extensive now, but still, I think it's about learning how this works, so that later on you can think of proper use cases in your enterprise work or your personal life that you would simply like to test out using SAP Business Technology Platform. So that's the naive rec example. Evgenii, you wanna take over to go a little bit deeper into some advanced rec use cases?
Yes, correct. Thanks a lot, Rui. So, first of all, maybe also covering and emphasizing that the overall stack, so the AI core, the generative AI hub inside of SAP, these are also the tools that we use delivering our own cases. So if you're interested about the different solutions, about the AI features and so build, about Joule and so on, pretty much everywhere we are using these BTP services also for creation of our own generative AI use cases and embedded features in SAP products that are available there. What we show today is rather, as you can see, we're focusing on the for developers story of how the developer would create custom scenarios for your applications using BTP and the services available there. I also want to emphasize that the coding that Rui just showed you, and this is where it makes sense to start sharing my screen. So let me quickly show you basically these tools and that repository uses and it demonstrates are based on the open source tooling that SAP provides for the developers. So the code examples you've seen are based on generative AI Hub SDK that allows us to, it's publicly available, and that allows us to work with the models provisioned on the AI core as, for example, standard LangChain LLM objects, that opens up the whole LangChain ecosystem of examples available there to give it a try, working with the models provisioned on AI Core in the same way as you would with standard, let's say, direct connections to the to the models as well. Similarly, so for the RAG scenarios, as we mentioned, we use the HANA Cloud Vector Engine there. And again, you could see on the LangChain side for the vector stores, it's actually under integration vector stores. You could find there the SAP HANA Cloud Vector Engine. And it's part of the LangChain SDK with a number of examples that show how to use it and basically specify the interfaces we created there for consuming all the classes and connecting to HANADB. On the RAG side, what Rui showed is basically covers the so-called naive RAG example, as we can see, for example, in this picture. And as soon as you start with benchmarking your application, and normally this is something that we recommend to start doing very early in a project to set up a benchmark, could be as easy as a data set of golden questions and answers. And you need to measure how close the results of your LLM application, your RAG application that you're building are to the target states to have some objective measurements and metrics. There are a variety of open source frameworks, for example, that can be used to do this measurements. To mention some, maybe RAGS, and I think we could provide the links in the session description as well. So. And nevertheless, the naive RAG examples, they have a lot of downsides that need to be worked on to really achieve a good quality of your application. And one such thing, just to name some, the user queries could be ambiguous and basically not precisely specifying what the user wants to achieve. In fact, there could be multiple questions that the user provides. Maybe model is not up to the task and so on. Oftentimes we see and experience the problems with retrieval. So for example, when we're not retrieving the documents that not retrieving the right documents with just a vector similarity search. It could happen quite often because the embeddings model that I used trained on the very generic data, and for your very narrow domain, they may not interpret the terms correctly and therefore may not deliver the best results. But there are still some features and techniques that we cover. Oftentimes we also see that the pre-processing of the documents also has a great effect. So basically, normally we are not ingesting the whole documents as one content piece because it's just too big. It could produce its own side effects like drifting of the LLM's attention to the context that is provided when this context is just too big, when LLM tends to forget pieces in the middle of the provided context and rather emphasize the parts in the beginning and in the end. So basically the documents, and also to deal with the limited context windows, as well as to improve the overall price per query of your LLM-enabled application, you may play around and see what chunking strategy is good for you. So in this advanced RAG folder, we actually cover a number of techniques for the advanced data splitting, which shows different chunking strategy, how different chunking strategies can be implemented. We also show the possibility of a self-query, where additional metadata that is stored along with the actual context piece in HANA Vector Engine can be used for pre-filtering to basically limit the context that we want to retrieve and serve as an additional conditions for the vector similarity search, as well as some aspects for the query transformation. And for the sake of time, I would focus on the query transformation example, basically show you two different patterns that are also quite handy in the query transformation. When this is useful, for example, imagine a chat scenario when you have back and forth with your RAG system and you refer to something by it. Normally, if your RAG system does retrieval on every step of the system, on every iteration, on every request, retrieving something without its name would likely result in a false context being retrieved. Therefore, the techniques like query rewrite using the message history could be quite handy when you can rewrite the query based on the previous conversation to be more precise. The techniques like RAG fusion can help you with basically expanding the user query and trying to come up with numerous queries based on the original user question, do the retrieval of these expanded queries, and then aggregate it to provide the results. One other thing I want to emphasize that normally it's not that you would just select one or another technique, but you would use it in combination. It highly depends on the actual data set and the goal you have for your LLM app. Let me nonetheless show you the examples that we discussed, and we're going to start in the advanced RAG folder, and we're going to start the option number 4. Rewriting the query. So what we see here is the original query, which is phrased pretty vaguely. We kind of want to understand that probably person wanted to have like key differences or some of the decision points to consider when selecting a different runtime on BTP. But basically, retrieving the information based on this may result in a very may have way bad results. Whereas if we use the RAG fusion technique and we rewrite this query first, we could see that we essentially rephrase this into a much more concrete question that gives a way more well-rounded answer to the question from the user. Similarly, so for the RAG fusion, let me also run it again. So again, we ask the same question, but this time, again, we first fire the query right away, and we see that the answer from the LLM is already like the question seems to be unclear. That's the statement from the LLM, although it tries to answer the question based on what it was able to retrieve. And if we call with RAG fusion, we see that we first generate a number of questions based on the original one about the benefits of one solution over the other, and so on. And then we do the retrieval step based on these questions, having a way more information to actually correctly answer the question from the user. So again, I want to emphasize that for applying these techniques, you would normally want to have a benchmarking setup and then experiment with different techniques, or maybe even use some tooling to detect what requires the optimization, like where in your performance of your LLM application you may have the biggest optimization potential. That is what I wanted to show regarding the advanced RAG. And again, feel free to explore the repository. There are some more examples covered there for other areas as well. As also we showed at the very beginning of the opening of the slide, in the repository, we could also see there are some examples of working with the multimodal models, especially with the vision models that are available in AI Core. So also feel free to check how to call these APIs. And what I wanted to show is actually the example which we also oftentimes have asked by our customers, which is the mixed RAG example. Let me open this in preview mode. And I need this picture. So basically, oftentimes we need to combine in our RAG system structured and unstructured data. And the example could be, again, pretty practical. Maybe you have some standard tables for your RAG app that are available in S4, or pretty much any structured data that you may have stored in the tables. And you would like to combine this with the unstructured data and the Retrieval Augmented Generation app. You want it to work on both. And there are different ways of how this could be implemented. A particular one that we show in this example number 4 is the agentic approach to it. Here, it is important to define what is an AI agent. Essentially, AI agent is a system, especially if the AI agent is based on LLM, a system that has certain properties, like it is able to create a plan for resolving the problem that user presents, that can use different tools to resolve this problem, that can also assess the results, make observation and assess the results, rewriting the plan if needed, and that is capable of multi-agent communication as well, so ability to talk to other agents. And in this example, we show how this task of a mixed RAG can be done with an agent, which we do based on the LangChain example of the SQL agent, which we enrich with a custom tool that we create for RAG, for RAG with unstructured data. In the example, we have a table with the information about countries, cities, and in the population, and also the Wikipedia pages for the mentioned cities. And we will ask a number of questions to the system, and we're going to see how the agent is able to combine this structured and unstructured info. So, here I have the example questions that I'm going to use. It's in the README. So let's switch to another folder. Example 4. Let's run the app. So we first start the ingestion step. So the first thing we do, we create a table, and for it's important to mention that in this case we actually use one and the same HANA cloud instance to serve as the provider for structured and unstructured data, but you could actually decouple these. So this could come from 2 different sources. The first thing we do, we insert the example. We create a table and we insert the data about the city, population, and respective country. And then for the cities, we fetch the Wikipedia pages there, chunk it, embed it, and save as a source for the grounding. We also then preview the information that is stored in the another table with the wiki pages information. So with the text, metadata, and the vector representations. It's just a portion of a vector, by the way. And as covered in the example, also, using the LangChain HANA objects, HANA vector store object, you will see that by default, it creates when you ingest data with this retriever, you will see that it creates a table with 3 columns for the actual raw text, metadata, and the vector representation. And here we only plot like the first 100 characters, I think, because the actual vector is way longer. So now as the ingestion is done, we're going to run the retrieve part. And we will ask some questions. So the questions are structured differently to address like different aspects of the system. So this question, for example, can you give me the country corresponding to each city? This question targets mainly the structured information. So it needs access to the structured data, and it can resolve it using the SQL tools. So there is no need to call in for the RAG tool and structured data. And let's see what this agent will be able to tell us. See, we plot the actual thought process and the reasoning of an agent, and what you could see there that like immediately the agent analyzing the query created a plan that to provide the country corresponding to each city. It needs to check the schema and see which tables are the good candidates for getting this information from. And it detects that the city stats table may have this information. It also retrieves the create table to better understand the domain, how this table is structured, to create a more to properly create the statements to this table, as well as it fetches just the top 3 rows to see what kind of data is inside. And then it's basically by knowing what is inside of the table, seeing the sample data, it's able to construct the statement and reply on the user question, coming up with this final answer. So all these statements were constructed and executed by the agent, so these were not hard-coded. The agent uses the standard SQL agent from LangChain, as I said, and it in turn uses the SQL Alchemy syntax to construct the actual SQL queries, which fortunately HANA supports. So you can run a variety of examples there for creating the queries in this way to your HANA database. So the next question would be a question to the unstructured data. So we're asking about the history of valuing, and we could also shoot the same question. And we see that the agent on the reasoning and the planning step decided that, okay, I'm going to use the RAG tool and just fetches this information directly from the Wikipedia. And the last question we're gonna try out is this one. So basically, this is a mixed scenario. So to answer these questions, we would need to first fetch the city with the highest population based on information we have in our database, and then ask for a RAG tool to retrieve more information about its culture. So let's go ahead and shoot this one and see the reasoning. And this is exactly what we observe. So it created a plan to basically to identify the city and then retrieve the information. And it follows pretty much the same pattern, exploring what data is available, finds out the city stats table, constructs an SQL statement to this query using the order by population, determines that it's Tokyo, and then calls in the RAG tool, constructing the query for the RAG tool, tell me about the arts and culture of Tokyo. And thus we have the final answer. So this is, it's not the only way, but this is one of the approaches of how you can create the RAG systems that are able to work in both structured or unstructured data. The beauty of it, as I said, is also if we check the implementation, that in fact we can, let me show you first the retrieve step in the code. So basically we create a retriever, we create a connection to our database, and we create the agent, which is based on the create SQL agent from LangChain, which we further extend with an extra tool, which is a RAG tool. And the RAG tool is a class that we define. Agent is able to select the right tools based on the description of a tool. And here we provide some hints for the agent when it makes sense to call in these tools, exactly stating that it has some information about the Wikipedia. Also of an interest here may be the prompt that's used. So here you could find the actual prompt we are using. with some instructions on the syntax and the dialect that will be used to construct the queries, some additional instructions, and so on. Again, in a real-life application, you would be very cautious on what user you use for executing such queries, and should have the least privilege principle, maybe even the restricted rights for changing or creating new data in the system, but may read it. So that's an important aspect to take a look on. Then we just provide the few short examples of how the good examples could look like. That is it on my side. Well, thanks a lot.
Yeah. Although it's a starter kit, we already went into some details with you. So that's also the purpose to really get something tangible. And I think also what Evgenii just showed, you see how sophisticated this can already be within the scope of this starter kit. And I think it's a great learning opportunity to get into the topic.
So we have a couple of questions that have been answered in the chat. Thanks for helping me doing that. I think we can repeat the one or the other, and then there's two new questions at the bottom. I think one of the questions that repeatedly was asked was if the AI core was available also on the trial account of BTP, and that's not the case. So you have to go for a regular account. I'm not 100% sure to which extent AI core services are available as part of the free tier, but that would be the starting point, I think. Then there were also some side questions about Joule. We're not the Joule experts sitting here, so bear with us. We can't answer everything, but in general, Joule is on a different level, and that brings me to one of the other questions that were in there from Raghu. Raghu asked, is there no relation with GenAI and Joule build app and build code? Is that something that we kind of can sort out here? Maybe Rui or Evgenii to see what are the different levels where we look at when we look at the starter kit and AI core versus Joule build apps or build code.
Rui, I think you're muted.
Yeah, we can't hear you, Rui.
Hello, can you hear me now?
Yeah.
Yeah, thanks a lot, Peter. So let me try to give it a try. So in essence, I think it's important to understand what the AI core service is good for. So the AI core service is, let's say, the one-stop shop on the SAP Business Technology platform to get access to all the large language models that are provided, right? And we do not concentrate on one specific vendor. For those of you who are actually within that space, you can already guess by the names of the large language models that they do not belong to the same company or to the same framework, right? So meaning that the AI core service is the core of the GenAI capabilities for the large language models, meaning that the only thing you need to do is not going to any other vendor and create somewhere an account there. No, you go to the AI core service, you tell which large language model you want to have. And then this large language model is deployed for you on BTP, right? So meaning that's the whole purpose of AI core, whereas let's say the AI capabilities built into other tools like SAP Build or maybe also a line of business solutions like S/4HANA. These are things where, of course, SAP is also drinking their own champagne, right? So we also make use of our own technologies and also get the same benefits out of it, right? But in essence, I think it's important to understand what the AI core service is good for, and then I think it was also related the AI Launchpad, which is also there so that you have a good visual understanding of how you have set up your AI core service with which large language models. In the starter kit, we have not used it because we wanted to make it as easy as possible just to get started. But in case you want to actually have a visual representation of what you have deployed as large language models on your BTP sub-accounts, that's where you need the AI Launchpad for, to really get a visual representation and also to manage this via an UI instead of using the APIs that we are using in the starter kit, which you, of course, you can also do, but here, of course, you need to have some more programming skills. So AI Core Service is there to access all the large language models in the starter kit, and the AI Launchpad is actually if you want to get more visual and actually also see and manage things in a Launchpad instead of using the APIs.
Thanks, Rui. There is a follow-up question to that, which is, what is the technique used by AI Core to create and use LLM?
Maybe that's something maybe that Evgenii can understand.
Yeah, absolutely. I can take this one. So, colleagues, AI Core and specifically the generative AI hub inside of AI Core provides you access to a variety of different LLMs from different vendors. I'm going to post in the chat. There is a link to the there's a link where we can send to the actual help pages of AI Core and the GenAI Hub, where you could see the actual models that are supported. There are multiple offers from different vendors, and that's the best place, I would say, to check what is currently supported. Maybe I can quickly share that. Here we go. So in the SAP AI Core help documentation, there's a specific section for models and scenarios available in GenAI Hub. And you can see the currently supported models from different vendors. So we have models from AWS, a variety of models from Azure and GCP as well available for you to create your custom applications. We try to keep this up to date. So basically, as soon as something new appears, we would review this and make it available as well. So please stay tuned to this page in case you're interested in some specific models and so on. Basically, the question was also related to provisioning of this model. So basically, behind the scenes, that's what AI Core is taking care of by connecting you to the right large language models. And some of these are hosted by the cloud providers. Some of these, as you could see, are actually open source and hosted by SAP. And again, I just referred to the documentation of the GenAI Hub for you to explore the details.
So in essence, what you get is from AI Core is an API that provides you access to all these models, regardless of which model you're currently talking to. So you don't have to deal with lots of different APIs and subscriptions and everything. As Rui said earlier, it's a one-stop shop for doing that. And it's for the coding level, right? While Joule is like a conversational agent that's sitting implanted into all the applications. That under the hood also makes use, of course, of generative AI technology to help you and answer your questions and take action on behalf of you in one or the other application. But that's then kind of a more advanced scenario comparable to what Evgenii has shown as an example. So there is more behind than just an LLM answering questions. It's a lot about getting all of the knowledge into the Joule system about the applications of SAP and technologies of SAP, so that it's really capable of answering correctly.
Thank you so much. Let me at this point really thank you so much for your excellent presentation and for answering all the questions in the chat. The GenAI Starter Kit will really make the developers' life easier, at least those that want to start looking into using large language models for their applications. And therefore, I think you really did an awesome developing an awesome tool there. And I cannot see any further questions, so let me thank our audience for staying here, for joining us. I hope you got a lot of value from this session. And if you have any other questions popping up after the session is over, please write them in the comments area underneath this video, and we will come back to you for sure. And with this, have a great day, have a great evening, depending on where you are.
Bye-bye.
Bye.
Thank you. Bye.